We have a quartic equation. Show that this quartic equation has two real roots and the two complex roots. And we know that for the fourth power polynomial equation, it has a four roots. Okay, this equation must have a four roots, and it could be no real roots, four complex roots. That is one possibility. Two real roots, two complex. That is another possibility. Or four real roots and then no complex. Only three possibilities. Why? Why it has only three possibilities? Because the complex roots must be paired. Paired. It, it means that if one complex number is a root and its conjugate will be the other, therefore the complex roots must be even number. Well, let me try to explain why. Okay, we have a polynomial equation, and the polynomial can be factored. Equal to 0. And these factors, either linear or irreducible quadratic. Linear, irreducible quadratic, and so on. If this one is reducible, then you can reduce the quadratic into linear. It becomes linear factors again. And the linear factors, from linear factors, we have real roots. From irreducible quadratic, you have complex roots. Now, if this is irreducible quadratic, this is this. C equal to 0, which means x equal to, right, 2a minus b squared for ac. If this is irreducible, which means this must be a negative number, so you cannot reduce to linear again. So you see, that's why it comes up two conjugates, two complex numbers which conjugate each other. So this is the reason why the complex must be paired. So this equation must have only three possibilities. Okay, that's number one. Number two, now this polynomial, well, the intercept is minus 39. Okay, the curve, this is dominating term, x fourth, that's the dominating compared to the other terms. This is positive. So when x is a large in number, and the curve looks like this. When x is a very large negative number, this is like that. Because this is very large compared to other terms. And then, because of the polynomial is continuous, so the curve must look like this. Then you have two real roots. Or it could like this, right? Then you have four roots, four real roots. So at least they have two real roots, which means that this equation must have at least two real roots. Yeah, this argument is not really mathematical. Now let me put this way. How about this? f of x equal to 4x fourth minus if this is f of x, then f of a 0 is a minus 39, which is less than, and f of a negative 1 will be equal to 4 plus 20 and plus 65 plus 40 minus 39. Wow, that would be positive, right? So between this, so therefore in this, she must have a root. Must, you must have a real root in this. See, it must have a one real root, right? Okay. Once you have a one real root, then this is not possible, right? We have a real root. So only two possible cases now, this case or that case. So we must show that it also has a complex root. See? Then we answer the question. Now, how do we show that it has complex roots? I'm using the relation between the relation between coefficients and the roots. Well, I have a video showing that the detail, and you can go see it, and the linkage is below. So for this particular equation, this one has four roots. So alpha, beta, gamma, and the delta. Okay, and also that alpha plus beta plus delta, gamma plus delta is equal to negative 20 over 4 equal to 5. Okay, you may see the detail in another video. The link is below. Okay, that is the relation between roots and coefficients. And also that alpha beta plus beta gamma plus gamma delta plus alpha delta plus beta delta plus the other one is this alpha gamma, right? Yeah. Okay, that one is equal to negative 20 over, sorry, 65 over 4. Okay. Then the alpha plus beta plus gamma plus delta square is equal to this plus twice plus beta gamma plus gamma delta plus alpha delta plus beta delta plus alpha gamma. So this one is equal to alpha square plus gamma square plus delta square plus twice. This is 65 over 4. This side is 5 square. So therefore alpha square, beta square, gamma square, delta square is equal to 25 minus 65 over 2. So this one is equal to negative 15 over 2, which means that the sum of these 4 roots square is equal to this. And since they are positive, this is square, right? Square, square. And this is negative. So one of them must be complex. Therefore, see, one of alpha, delta, gamma, delta must be complex. Must be complex number because this is negative. They are squares. And therefore, you have this is not possible because we have complex. So this is the only case. So therefore, at least 2 roots are complex. Then combined with this, right? It must have at least 2, at least 2 complex, at least 2 real. Therefore, it has 2 real and 2 complex. That verifies this equation has a 2 real, 2 complex. Thank you.